Now that we know how to find dot products, one of the most useful things to use a dot product for is to find an angle between two vectors. And here's the formula. You'll need to write this down at the top of your paper. If theta is the angle between two non-zero vectors u and v, then the cosine of theta equals u dot v divided by the product of their magnitudes, u and v. So it's the dot product on the top and the product of their magnitudes on the bottom. So make sure you get that written down. Pause if you need to. All right, well, let's actually find the angle between a few vectors here. Let's find the angle between the vector negative 1, 0 and 0, 2. Now, let's take a sneak peek here. If we're at negative 1, 0, that means it's going like this. Let me use a different color. We're going this way, and 0, 2 is up here. Now, you can just look at that and say, hey, those are 90 degrees apart. So the theta that we're finding better be 90. So let's take a look. We're going to use the formula. First of all, we need to know what their magnitudes are. That's a good place to start. So the magnitude of u, remember, it's just like Pythagorean theorem where you take the square of your horizontal component, take the square of your vertical component, add them together, take the square root. Well, I can see right now that this little vector right here has a length of 1, and this one has a length of 2. So therefore, the magnitude of u is 1, and the magnitude of v is 2. So let's get going on this formula here. The cosine of theta is the dot product over the magnitudes multiplied together. So 1 times 2, those are our magnitudes we just looked at. Now for the dot product, negative 1 times 0 plus 0 times 2, and we get a 0 on the top over 2. So we are looking at a cosine of an angle that is 0. And we know that when that happens, that our theta is going to be 90 degrees, or if you're in radians, it would be pi over 2. And generally speaking, we'll deal with degrees here. So that all worked out pretty nice. All right, let's look at the next one. Find the angle between u and v. We've got these in a linear combination form instead of component form. So let's find our magnitudes first. We have u, and that's going to be the square root of 25 plus 4, 5 squared and 4 squared, so it's the square root of 29. The magnitude of v then is the square root of negative 6 squared plus negative 1 squared, which is just 1. So this is the square root of 37. I'm going to take a quick look at what these look like and where they end up. So I have 5i, 1, 2, 3, 4, 5, 1, 2. So here's u. It's like this. And then v is at negative 6. 1, 2, 3, 4, 5, 6. And then it's down 1. So it's down here. So it's a fairly large angle in between these two that we're looking for. Certainly more than 90, but less than 180. So it's obtuse. All right, keeping that in mind, now we're going to use our formula. The cosine of theta is the dot product. 5 times negative 6 plus 2 times negative 1 over the product of the magnitudes. So the square root of 29 times the square root of 37. Now at this point I would recommend simplifying as much as you can. So in this case it means the cosine of theta equals, on the top we have negative 30 and negative 2, so that's negative 32. Now when you take a radical times a radical, you can simply multiply the numbers that are underneath Taking 29 times 37 gives us 1,073. So now we need to find out what this angle is. Calculator time. Theta is the inverse cosine, and the good thing we're using cosine because inverse cosine because it is an obtuse angle we're looking for. Parentheses, negative 32 divided by square root of 1073. Finish the square root, finish the inverse cosine, type it in, and we're getting about 167.66 degrees. Again, pause if you need to anytime. Double check that for yourself. Know how to do it yourself. So there's finding the angles between two vectors. In the next section, we'll look at special angle relationships.